Well, folks, we've got one from the trade. It's a Midland 2001. I'll just show you its face, and it's been sent as a chassis only. The original, the owner, who is the other dealer's dealing with, its sentimental value as a father. It's been reverse polarity. Somebody's put a uniden type connector on the back. Probably didn't realise we sold the originals. Of course, that means they've carved out the chassis, which you can't now fit in the original type. I mean, if this was mine, we would be taking a scrap outer chassis, because it's not that difficult to do. All you've got to do is to unsolder with a great big 200 watt iron the heat sink, the shield plate there. It's not that difficult, and undo a few of the things that go to the chassis. So as part of what he's done, the dealer, is to replace the audio IC. So it's been reverse polarity, which was no good. We've now got PA working on this. You know, that's how he sent it. He's replaced the output transistor, because the same applies. There's no transmitter or no receiver. We've got a clue. There's a clue here, and here we go. The meter bangs across when you power it up. We're in PA. The meter still bangs across. Now, for that to, I've measured the voltage on the back of the meter. It's 2.4 volts. There's a short circuit somewhere. So what we're going to do, because it could be coming from two directions, could it not? It could be coming from transmit, it could be coming from receive, because the meter is used in both. So it's RV4, if I remember rightly, is the S meter for receive, and it is, or is that, no, that's going to be transmit, because it doesn't have one on receive, does it? Resistor 99 drives it from transmit, if I remember rightly. So we'll just look in. What I'm going to do is to take out, yeah, it's that one there. Let's take that off. So if I remove that preset, I'll tell you what, let's measure the voltage on that preset and save me the bother. I'm going to say we take the preset out, and then we can see where the voltage is coming from. Just check it's a negative chassis, or is it a floating chassis, or are we not on? Yeah. So I'll put the power on. I don't want to burn the meter out. We're going to keep it in PA. We'll see whether there's a voltage on that preset. There is. I think, therefore, it's coming from the transmitter. Because it doesn't matter which pin, I think there's only two connected. We've got 2.4 volts, and on the wiper, if we can get to the pin, just actually touch the wiper, we've still got 2.4 volts. So I'd expect there to be a difference. I think if we whip that out, it's going to help us in our diagnosis. But I'll do that and pause the video. Well, folks, we've got one from the trade. It's a Midland 2001. I'll just show you its face, and it's been sent as a chassis only. The original, the owner, who is the other dealer's dealing with, its sentimental value as a father. It's been reverse polarity. Somebody's put a uniden type connector on the back. Probably didn't realise we sold the originals. Of course, that means they've carved out the chassis, which you can't now fit in the original type. I mean, if this was mine, we would be taking a scrap outer chassis, because it's not that difficult to do. All you've got to do is to unsolder with a great big 200 watt iron the heat sink, the shield plate there. it's not that difficult, and undo a few of the things that go to the chassis. So as part of what he's done, the dealer, is to replace the audio IC. So it's been reverse polarity, which was no good. We've now got PA working on this. That's how he sent it. He's replaced the output transistor because the same applies. There's no transmitter or no receiver. We've got a clue. There's a clue here, and here we go. The meter bangs across when you power it up. We're in PA. The meter still bangs across. Now, for that I've measured the voltage on the back of the meter. It's 2.4 volts. There's a short circuit somewhere. So what we're going to do, because it could be coming from two directions, could it not? It could be coming from transmit, it could be coming from receive, because the meter is used in both. So it's RV4, if I remember rightly, is the S meter for receive, and it is, or is that, no, that's going to be transmit, because it doesn't have one on receive, does it? Resistor 99 drives it from transmit, if I remember rightly. So we'll just look in. What I'm going to do is to take out, yeah, it's that one there. Let's take that off. So if I remove that preset, I'll tell you what, let's measure the voltage on that preset and save me the bother. I'm going to say we take the preset out, and then we can see where the voltage is coming from. Just check it's a negative chassis, or is it a floating chassis, or are we not on? Yeah. So I'll put the power on. I don't want to burn the meter out. We're going to keep it in PA. We'll see whether there's a voltage on that preset. There is. I think, therefore, it's coming from the transmitter. Of course, it doesn't matter which pin. I think there's only two connected. We've got 2.4 volts, and on the wiper, if we can get to the pin, just actually touch the wiper, we've still got 2.4 volts. So I'd expect there to be a difference. I think if we whip that out, it's going to help us in our diagnosis. So I'll do that and pause the video. Alright folks, I've done that. We'll connect it back up to power. Switch on. See where it still bangs across. It still bangs across. So the source of the short circuit is no longer there. So the source of the short circuit must surely now be on the receiver. So what we're going to do now is to find resistor 99, which feeds the meter from the receiver, and we'll remove that. Right, so behind the scenes, I disconnected resistor 1009, which on the circuit diagram is the feed from the receiver, and no difference. I then thought having taken out the preset for the transmitter relative RF power, and it's still having the 2.4 volts, I thought, well, there shouldn't be anything else. But I then find there's this yellow wire, and this yellow wire, if we go to volts, put the set on, that's 13.8 volts on it, and of course it shouldn't. So now I'm on PA, and we've got no meter with that yellow wire disconnected. Everything else is connected back up. The preset's back in, and resistor 1009's been replaced with a new one, simply because it snapped coming out. Testing 1 2, testing 1 2. Talk to me. No, it doesn't want to talk to me. Why doesn't it want to talk to me? Would that be because I've got it in the wrong socket? Yes, there we are, that's PA. That's all I needed to do. Let's go to CB. So we had that before. Just see whether we've got any signal coming through. I'll put 2779125 on the signal generator. So it's as deaf as a post. We're looking at 300 microvolts there. We'll just quickly check it's not stupidly out of tune. We'll just do it by ear. No. It's having no effect, is it? That one is. That one's having little effect. See what happens in transmit. So it is generating the channels. So what's happening on just put the squelch on. Oh, squelch not doing anything. Ah, well there's another clue then, isn't there? Squelch not doing anything. Well, Mr. Tango. So that's something else to look at the circuit about. I did these blow-ups to enable me to find the part. There was 1004 where I've replaced it. So I'm going to get my walkie-talkie, see if it's generating the channels. Testing 1 2, testing 1 2. So it's generating the frequencies. So I will just check our 8-volt regulator is doing 8 volts. Remember this has been reverse polarity, and that usually means with no fuse. So it's 8-volt regulator, so 13.8 and 8, that's absolutely fine. So if we've got no transmit, I'm going to now look at the ammeter when I go into transmit. And it makes very little difference. It's 236 milliamps and it rises to 260 milliamps. So that now tells me, do we actually have... It's just destroyed a lot of stuff, hasn't it? And something's causing that yellow wire. I'll look where on the circuit that's connected to the preset. Something's short circuit and passing full rail voltage. So without trying to short that out, let's just look at the... Oh, that's made power come off. It'll continue to do that, won't it? So our driver transistor is somewhere. Oh, it's there, isn't it? So we'll key up. Oh, I put the mic the wrong side. Nothing. Key up. Nothing. And nothing. So it's not getting as far as the driver transistors. We're looking at the earlier stages. It's actually using an RF voltmeter. I'm just going to do a little twiddle just to see whether we have any difference on the current being drawn. No effect. no effect. So he's not getting that far. Right, I'll have a look at the circuit diagram. I think it's going to be one of those. I've got so much on at church at the weekend. We'll probably still be doing this set on Monday, and it's Friday at the moment. So I think we'll put this. I'll take the soldering iron off. I'll have a look on the computer so I can just blow up the circuit diagrams a bit better. So quite a few days later, we're going to have had this on the bench a week soon. We've got a situation where there's no voltage on the collector of transistor 11, which is the driver transistor. I changed the choke there as a precautionary thing, though it read right, and the resistor's right. The resistor's been replaced there, but we've got no voltage. Now I've got a scrap chassis, which is greatly appreciated, and with courtesy of Quotages. This isn't quite this model, but it's been a good donor for some of these small components that, you know, even when chassis are smashed up like this, there's still some valuable parts to be had. So we've got that situation where the voltage should be there, but my board differs slightly. I don't know why my board differs slightly. So what we've done is I've just gone over to stores, and we've got another Midland 2001 out. So what's this one? November 81. Could be a different version. So that's what we're going to have to do. We're going to have to take this one apart, and we'll see if we can find out if there's any differences. And this set will be subject of another video in a few weeks. It's one that Alan, our mystery benefactor, very kindly passed on to us. The trouble when you've got a situation where a radio has been reverse polarityed and the protection diode has failed and there's no fuse, and it just starts blowing components right, left and centre, and the supplying dealer has, as I mentioned earlier, is replaced the audio IC and restored public address, which is a jolly good start. So we'll just pop that speaker off. And see if we can see any difference. Not sure what that resistor's doing there. Well, that's kind of what I would expect. No preset for low power, but that preset can seem to be to turn into S meter on some sets. And of course it's this whole area that where our snag is. It would be, wouldn't it? Right, so I'm going to do some very careful comparisons. Well, absolutely bonkers. So, if we look at the circuit diagram, I don't know whether somebody swapped the board on this or what, just as if it's not the right version for what it is. We've got resistor 144, which is a 1 watt resistor, which is the power feed to the driver and subsequent stages. So 144 has been checked out or replaced or whatever. And then we've got 143 there, which is 1K. I think 144 is 10 ohms. Just check, yeah, 10 ohms. Then we've got a choke. So the power is from the on and off switch, straight from the on and off switch to this 13.8 volt rail. So you've got the collector of the output transistor through its coil and its resistor straight to power all the time, and then you've got this on all the time, because this set doesn't have high-low power, but there's places on the board that say 4 watt and 0.4, and on my version there's a link between 4 and 0.4 because you don't have high-low power on the 2001. But this has got extra wires and things, and that isn't linked and doesn't look like it's ever been linked. Well, on the board, resistor 145, which doesn't show on the circuit but must be on another version, you've got a break between that coil and the collector of transistor 11. And I've just put a wire link in, which is where resistor 145 could be on another version, and that's now restored the power to the collector of the transistor. So let's go over to our, we'll just put picture in picture on, because I think we're going to have to transmit now. Let's just do that. So key up, and there we've got a good 3 watts, 2779109. That's my meter telling me to do things. So we'll just do a tune-up on that. So we've got peak there, because I peaked them for maximum into my monitor receiver. 3.6 watts. I think I've done that, haven't I? Yeah. And that one. And then that one's never been touched, so we will touch it. You've got 2 here, haven't you? We've got, I can just find the right tool. I don't want to have this RF voltmeter on this bench anymore, do I? So we've just gone, without touching the final one, which is there, we've got 4 point a little tiny bit, and that's on channel 20. Yeah, let's go to another channel. Channel 40, 4 watts. Channel 1, 4 watts. Now that link hasn't, this is why when we powered it up, we got the meter showing full scale deflection. We've actually got the meter working without its silly wire and actually reading about 4 or 5. By the way, I had a question a bit back about somebody's meter not reading. He says £5. I don't know what he means by that. But when he transmits, well, it's supposed to be 4, isn't it? And it's just under the 4 on this. And we'll actually set that. We'll set that right now while I'm discussing this. Which is there. So into the dummy load, we can of course vary this wherever we want. We've just set it so it's between 3 and 5 because it's spot on the 4 watts. So that's where we are. But if I put this on an aerial instead, and I'll do that right now. So we're going to transmit on an aerial. We'll just plug in our Antron 99. It isn't going to read 4 anymore. It's going to read something totally different. Sometimes when we put a radio on the aerial, it will bang across. Sometimes it will hardly move, but it's still doing 4 watts because the meter is subject to SWR reactance and so on. Now look at that. It's banging across. Bang, bang. But the radio is still doing 4 watts. Means nothing. And this could be why manufacturers have started to put fake meters on, which are pre-programmed to read something or other. And even when those sets aren't transmitting, this is nearly every new set, even when they're not transmitting because they have a malfunction, you could even take the output transistor out and the meter will still bang across as if it's transmitting. So we're back to the test instrument and it's bang on the 4 where I've set it. So there you are, that's a demonstration. Oh, Mr. Tango, you're doing more than 4 watts. No, I'm not doing more than 4 watts because it's subject to the SWR, etc. So few parts changed there, and a link put in which probably doesn't even go there, but I've got to make that circuit. Whatever's missing isn't the same on my demonstration set, because my demonstration one is an earlier one, first batch, and they've fixed one or two little things. These little afterthoughts have been fixed on this later one. Don't know what they've done, but I've fixed it. This doesn't bring back receive. This set has another malfunction to stop it receiving. So I think what we'll do, we'll just set the deviation whilst we're thinking about this. There's a big trail of destruction when somebody reverse polarities a set after there's no protection anymore. So let's see what the deviation is on the test set behind me. Just change glasses, I'll never see that. Wow, it's actually about 1.9 to 2, something like that. So it needs to come up a little bit. And if I can find my correct trimming tool, it's the preset just hiding under that wiring. Wow, that'll do. And out of interest, we'll see what my Marconi test set says. As I say, it's not quite reliable on its deviation meter at the moment. It's clearly got a duff capacitor in the test set, but I just can't take this off. Would there be no? I would guess it's a 28-day downtime, so we can't afford to do that. Right, let's see what the deviation is. Wow, it's actually reads exactly the same. So that's fine, it's working today. So we'll just listen to it on our talkie-walkie. I get that when I was working at Nottingham Radio, a customer rang in. Do you do them talkie-walkies? Yes, we do. Testing 1, 2, testing 1, 2, 3. So we've restored transmit. What's happened? I don't know what's happened. I'm sure my supplier doesn't know what's happened. I'm sure the customer doesn't know what's happened, because whatever's happened has probably happened 30 years ago. So I'll put the RF voltmeter away. Somebody asked if we've got a spare one to lend out, and I would do if we had a spare, but it's the only one we've got. I think it was about £35 plus post. It wasn't from Russia, it was one of those former Russian states. I think it was Georgia, to be honest. I don't think we're going to need the voltmeter at the moment, so put that away as well, clear the bench a bit. That makes a change. So we'll just pop it on frequency. I've really had to shorten this video. I mean, the hours of thinking which go into this. So put it on frequency and show the frequency counter. $27.79. $125 when we get there. Yeah, there we are, spot on. Good, so we're doing a full 4 watts across the 40 channels and the proper deviation. What more could you want? Now, the dealer supplying has changed the output transistor because that was blown. I've changed the resistor 144 because he's told me to. It's a temporary measure, he'd put a 1/4 watt one in, but I've recovered that off that scrap chassis that David sent, so that's all fantastic. No burnt out coils. So now we'll concentrate on the receiver. So we'll put 2779125 on the signal generator, and last time we looked at this it was 100 microvolts to even hear anything. That's an S9 signal to even hear anything. So you're looking at range of about 100 yards. So we'll set that nice and spot on. That'll do. And there we are, 100 microvolts. You can just hear it. So very quick tune, it's not going to make any difference. In fact, that coil's having no effect. That should be really, really sharp tuning. So we've got a duff transistor blown by the shenanigans. And that coil is... We just look at the bits of circuit I've printed off and get them the right way on. Just turn the volume down. There's no squelch operation either. I'll look at the circuit, because if there's no squelch operation, there could be no power to a circuit or the MC3357 which could have blown. Now that wouldn't affect the fact that it sets deaf. We've got a nice FM noise. I'll just see if we can set the detector, because if I put the signal generator to full whack, we're going to have a jolly good signal. Just put over to go to the oscilloscope. I'll take it from the... We're currently on the extension speaker we use as a PA speaker. I didn't want to blow up the test instruments if there was some major malfunction, so I put it on that. So we're now on the test instruments. It's a nice sine wave there. And let's see if we need to adjust that. It was absolutely spot on, so that is fine. So that's not a reason why the squelch control isn't working. And you'll remember I've taken some wiring away from the S meter, so it isn't going to work on receive till I find out how to restore that wiring, because they'd got rail voltage through a resistor going to the meter, giving it 2.4 volts. So I've removed that. I don't know what they were doing. I think what they've done is they've put a preset in where there isn't a preset, and we can put that back if we can find out how to wire the meter through it. Because on the early version, you haven't got a preset on the meter. You get what you're given, and I think there's some kind of attempt to make it variable, because sometimes it's also on the back of the meter. So we'll come to that, because that's all by the by. So we've got no squelch operation, and we've got def as a post operation. They may not be interlinked. On the other hand, they may be. So let's have a look where our shenanigans are. If I get this the right way round. Not back to front, is it now? Yeah, T5 is there. So T5 on the circuit diagram has no effect. T5 is here. So where does the aerial come in? Well, the aerial comes in there, goes through that filter, and it goes straight into T5. If that transistor was short circuit 104, it would be shunting the receive to deck. If that transistor was open circuit, we'd lose sensitivity and we'd have no effect from Q5. So we've got two possibilities here. (101) and 104. So I'll go and look at those. Okay, so I took out 104 because I found that first. I've taken out one, that was fine. Taken out 101, which is the first transistor in the aerial amplifier side of things, and it was showing as a duff transistor. So we've got to find an MPS 94 something. My scrap chassis already has had it pinched. 101 MPS 8246, does it say? 94 MPS 9426. So there's quite a lot of MPS 9246s used, so we can pinch one from somewhere else. 102 is also one of those. Well, I can see 105. That isn't one. I can see 113. That is one. Right, I'll get that removed. Right, so I've taken that out, and we'll see whether this this one works. Fine. I've got these in stock new, but we'll try and keep the cost down with him being a trade customer. Now then, I've got to try and I've got to try and thread it through. Solder up some of these other components which got disturbed along the way. Power it back up. So it's still as deaf as the post. See whether this makes any difference. And the answer is no. There's probably not even any power going to it, you know, but that transistor was duff. There's no two ways about that. Volts, 1 point something, 1 point something. So although we've effected a proper cure there, we've still got no joy. So I'm going to take a break and we'll come back to it. Okay, it's now Thursday, so a bit more on this radio, which goes on forever, and we've actually got receive right now at 3 microvolts. 3 microvolts. So turn the attenuator down, that's 1 microvolt, so it's now working normally. Basically there's wiring wrong, and it's taken a lot of sorting out. We've got a positive 13.8 volts appearing just here. So it's muting the receiver. When this radio goes into transmit, the transistor there puts the input signal, which is this one here, coming out of the filter. This is the receiver's input, and it puts it down to deck by triggering the base of the transistor 104. So this is getting a high all the time because of the 13.8 volts. And so I found that the first transistor in the actual receivers here, if I put my input there, it was pretty normal, but it was being muted by here. So it's just a wiring thing, just like we had no 13.8 volts to the transmitter, hence it wasn't transmitting. We've got an all the time 13.8 volts muting the receiver as if the wire's in the wrong place. But you know what? It didn't look like it had ever been removed. So whatever's happened to this has probably happened 30 years ago. I just do not know what's happened to it. So now we should be able to tune the finish tuning the receiver. We did the detector. So we'll go with, we're on the synod meter. This should now have effect. And it does. That's fantastic. I think the others should be alright, but we'll check them anyway. We'll tune them under fault condition. Yeah, they're all spot on. So now we've got 0.44 of a microvolt. So we had one of these transistors blown, that transistor blown, that transistor blown, both those blown. There you go. And the feed resistor 151 blown. So now we've got to kind of get the meter to read something. Because it's all that wiring that's been... I think this set has been one of those which doesn't have a meter preset. I think somebody has tried to wire a meter preset into it, and I think this is where it's all gone pear-shaped. So this does show a meter preset. Check we're still correct on transmit. Yeah, that's all spot on. So how are we going to implement this? So that's all that's left to do. Squelches work. Oh, set the squelch up. Let's do that. So 100 microvolts on the signal generator. Let's go over to the attenuator. So I'm not writing any of these parameters down. It's a chassis for a trade customer. You'll no doubt watch it. So I want on full squelch the radio to work when it's 100 microvolts. It's a bit premature at that. It's one of those, is it? Well, it's 10 microvolts, so it's not the best. Let's turn it to the sensitivity bit. It's coming in at 0.3 of a microvolt. So the full squelch isn't that brilliant, but there you go. You don't know what other things in the squelch circuits have been strained with having 13.8 volts. And what we can't start doing is changing so many parts. It's gone beyond a joke anyway. Right, that's acceptable. S meter. It's the only thing, and we've got to think of something to make it work. So it needs to, the meter, if I put the other glasses back on, I've had to take all the wiring out of the meter from the receive side of things. Right, and there we go. We've put a resistor in, and we've put it back to how it should be, which is non-adjustable. So what's that? 100 microvolts is plus 30, and 9 is in fact 50 microvolts, which is exactly how Maxon intended it to be. So that the S meter is preset as it should be. I think that part of the shenanigans, yes, it has been reverse polarityed and it's wrecked the radio, but previously it's had this, somebody's tried to modify the radio to have an adjustable S meter when this particular version isn't supposed to have an adjustable S meter. So there we are, everything's working. So with that, we're doing on the air test tomorrow as a chassis, and so I'll do mine in probably about 10 days. So that has worked out a nice working set. I've no doubt the dealer in question has done the protection diode. I don't think I'll pry into that too much, but I'm sure he has. I'll clean up the printed circuit board where we've changed so many parts, and we'll just pop it on the aerial and see if there's any good or bad buddies out there. I want to do a little review of a magazine again. And someone's put this Uniden thing, I did mention that in the beginning, but they've cut the chassis out, so I can't do anything about it. Oh, better put the extension speaker in. One Anna, Roger. Nasty scratch on the front. See if Mr. Chippie's out there. Mr. Chippie, do you copy?
Yeah, Roger, go ahead.
Okay, just testing this Midland.
Yeah, seems to be working.
Excellent, Roger.
Roger.
Good, there we are. Right, we'll do a on-the-air test with that as a chassis tomorrow. Oh, that was long-winded. Yeah, it'd be 6 days, but I can only kind of spend 45 minutes a day on it, and we couldn't do anything Saturday and Sunday with the level of church services. We're not going to be that far off this weekend. I've got a wedding on Saturday, so I won't be playing at radio. Thanks for watching.